All right, so next up, we're actually going to do some examples of what that looks like. If you think that you remember, go ahead and try the activity. That's fine. But at least listen to me for 1A and 1B to notice the difference between X versus a number. And then we'll be discussing domains for some others. Okay. So this is two polynomial functions, meaning there's no weird square roots or division, any of that. It's just polynomials is when you have x and possibly x with an exponent, but that's it. All right, so if I want to subtract, so 7x minus 5 is f of x, right? Because remember, this is f of x minus g of x. And then minus g of x is 3 minus 2x squared. Now, I remember I have taught this for years. Every year, people always want to add on some random x on the end because there's an x on the end here. They want to put x on the end of what they're working on. But recall that that x on the end just means that you're subtracting the two functions that are using x. So please do not do that. Do not multiply everything by x. Do not leave an x chilling at the end. Like, that's not what's happening here. All right, so from here, I am just simplifying, going back to some of my Algebra 1 skills. A negative times a negative is positive. Combine my like terms and write in decreasing order. And there we go. Cool. All right, so how is that different than the next problem that says f minus g of 4? The difference is that everywhere that there's an x, I am going to plug in the number 4. So notice there were two places with x there. Both of those places with x I replaced with 4. I simplify. So 7 times 4 is 28. Minus 5. Minus, I'm going to work inside the parentheses first. So 3 minus 4 squared is 16 times 2 is 32. Simplify that to get 52. So 28 minus 5 minus 3 plus 32 if I use the distributive property. Now also notice that if I use the function I was given here and plugged in 4 there, so 2 times 4 squared plus 7 times 4 minus 8, I also get 52. Okay, so that is why that works, and either way is appropriate. If you want to combine it in terms of x and then plug in the number, that's cool. Or if you just want to plug in the number from the start, that also works. Okay. All right, so this is a little different than what we did in Algebra 2, mostly because we didn't really do anything with square roots. Okay. So if I have addition, there's really nothing I can do to simplify that any more than just the two functions added together. Okay, for my domain, however, remember under the radical cannot be negative. That was called a complex number or an imaginary number. So, and weird things happened when that was the case, and so we don't like that. So in order for that not to be negative, that means that whatever's under the radical has to be greater than or equal to 0. Remember, 0 is okay because the square root of 0 is 0, so that's cool. All right, so that means x has to be greater than or equal to -1. So that's one way to write the domain. I'm cool with that. The other way to write the domain is to say from -1 to infinity. So think about that. If it's greater than -1, you're talking about all the numbers from -1 to infinity. All right, what does subtraction look like? X cubed minus square root of x plus 1. Again, there's really nothing to combine like terms with. The same is true here. We have the same thing under the square root. I would do the same work. There's no need to repeat, so my domain is the same. All right, multiplication. X cubed times square root of x plus 1. Again, all right, cool. And notice, same thing. The only thing that's not allowed is a negative under the radical, so that is still the same. So your domain for addition, subtraction, and multiplication are typically all the same. It's division that makes things weird, okay? So for f divided by g, again, there's nothing to simplify. That's as far as it goes in that sense. But our domain is going to be just a little bit different. Remember, for addition, we said that it could be equal to 0 because the square root of 0 is 0. However, recall that I cannot have a 0 in the denominator. So now x plus 1 has to be greater than 0 because it cannot be equal to 0. So all that does for the domain is instead of a bracket, it makes it a parenthesis. Okay. All right, so that's addition, subtraction, multiplication, and division. You have a little activity for a whodunit, so I'm anxious to